All right, folks, first ever calculus video. This is about the prerequisite chapter. This is all stuff that you should have known from Algebra 2. I know that I taught it to you. I know that you've seen it before, so it should all be a review. This is just to kind of get you started through P.1 or whatever you want to call it. It's the first section in the prerequisite chapter. It's all about solving equations. So if you know how to solve equations, then you're set here. Okay, I'm hoping that this is relatively quick. I have some examples that I want to go through so that you can see it. I have my book open right next to me on the desk, and I'm on page 4. So I want you to kind of look, actually it starts on page 2. So I want you to start on page 2 and kind of go through it with me while we're here, okay? So this is just something we're gonna be very good friends with our book. We wouldn't usually be because we have online, or if we had in-person stuff, but now since we have online, you're gonna have to get pretty friendly with your book because it's got a lot of great examples, okay? So as we kind of work through, I just want you to be able to see and go through some of these examples. It's got some really great worked out examples next to it. It's kind of hard to look at, but once you figure it out, you'll be okay. What we're kind of working through is we have a couple different things that we need to make sure that we understand, okay? As you look through this, there are things called solving an equation. You know solving just means find out what x equals. As you keep working, it says those things are called solutions. We have to know that there are multiple solutions. If you have questions about how many solutions something has or what those things are, make sure that you let me know. These things go through and they talk about things like identity and conditional statements and things like that. I'm not really super worried about that because the book starts out with linear equations. Things like 2x plus 5 equals 10. You know how to solve that. You know how to work through that. So I'm not going to waste your time in those things. Okay. Once we've worked our way through and we get into the higher level stuff, we'll start taking some time to really think about all of the definitions about the new things that we're learning. But these are all old things that I know that you already know how to do. So I'm not going to waste your time with it. Okay. The first real example that I want to make sure that we talk about are things that they're equations that involve fractions. I know you don't like fractions. I know you don't want to deal with fractions. In calculus, you have to like fractions and you have to deal with fractions. You can't use decimals 99% of the time with this. Eventually, we're going to get into trig functions, and when we get into trig functions, you cannot use a fraction or a decimal for that at all. Okay, you have to use fractions. It won't go away. All right. So let's look at what this will look like. Oops, I want to get out of that. I want to get out of this. So let's look at what this looks like. I'm just going to make an example. It doesn't matter what the example looks like. It's very similar to the example that you see in your book, but let's just make one up where we have like 2x over 5 plus 3x over 7 equals 4. Whatever it is, we have fractions. These fractions are different. Your book is going to go through it one way that's very specific that I want you to look at so that you can see what it looks like. All they're doing is they're saying that the denominators of these can be the same somehow. In this case, it would be 35. And you would multiply the entire equation by 35. A lot of you don't like doing that and you like using common denominators. It doesn't make a difference either way you try to do this. It doesn't make a difference at all. Okay, so what I'm going to do is I'm going to find common denominators here. So this one I'm going to multiply by 7 over 7. This one I'm going to multiply by 5 over 5. And then I'm going to end up with 14x over 35 plus 9x, it's 15x. Can't read my own handwriting. 15x over 35 equals 4. And then I'm going to end up getting 29x over 35 is equal to 4. I'm going to multiply both sides by 35 to get rid of this. So I'm going to get 29x equals 140. Divide each side by 29. Divide each side by 29. I just made this one up off the fly. And it ended up not being a super great equation, but that's okay because now we're just going to take our calculator and divide it. Your calculator is going to be a very good friend as you work your way through here. So like I said, you are probably going to tell me the answer to this is x equals 4.83. And you're right, but I don't like this answer right now. I like the answers in terms of fractions. Just like you see in your book, it likes it in terms of fractions. So what I would suggest to you is on your calculator, you get friendly with the math enter button because that's going to allow you to convert that thing into a fraction. So I could do 140 divided by 29 on my calculator, and I could change it from fraction to a decimal or whatever, and I could then try to fix it as much as I could. This, since 29 is a prime number, I'm not going to be able to simplify it anymore, so it's going to be stuck at 140 over 29. But there are two good examples in the book that are a little bit more difficult to deal with. The next thing that I want to talk about is extraneous solutions. I'm not gonna work you through the example 3 in the book because we did those on the SAT review, so I know that you've seen them. But as you work your way through, Keep in mind, extraneous solutions just means solve the equation. And when you solve the equation, make sure that you put the answer back in to see if it works or not. Okay, very simple, very straightforward. You know how to do that. Okay, so just keep in mind that sometimes things are extraneous solutions. Great example in the book that you should look at right on page 4. It'll walk you through it. It's got common denominators, non-common denominators, so on and so forth. That's when we have rational expressions, and that's the thing that you really need to pay attention to. Okay, so the next one is quadratic equations. When we're dealing with quadratic equations, we need to remember that usually they come in the form, so these are quadratics. So in quadratics, usually they come in the form ax squared plus bx plus c. And usually if we're solving them, not usually, always if we're solving them, we want them to equal 0. So as we work our way through here, we can say that this is a quadratic equation or a second degree polynomial. A polynomial is a combination of terms using x's. So like x to the 4th, x to the 3rd, x squared, so on and so forth. So since this has a degree of 2 right here, this is a second degree polynomial. We are going to be dealing with higher degree polynomials as we move on. Okay, so as we deal with these, we have to remember that this is factoring. We have to deal with this with factoring. All right, when we factor things, we then set them equal to 0. We're good to go. But there are a lot of different ways that we can break things down into factoring. The first way is we always try to break them down into x plus or x minus a number and x plus or x minus a number, and then that will equal 0. We set them equal to 0 and we solve it. That's really great. The next thing that we can try to do is if it's given to us in the form of something like this, if we have like 4x squared plus, I don't know, 16 equals 0. A couple different things we can do here. We can factor. Remember, we can just factor with little numbers like this where we have 4 and then x squared plus 4 equals 0. And then now we can divide the whole equation by 4 and we end up with x squared plus 4 equals 0. And we can solve this thing by using roots. Now, if we solve this thing by using roots, we just move everything over to the other side. So we end up with x squared equals -4. Take the square root, take the square root. So I get x equals, don't forget roots have plus or minus, and then we have a negative in there. So it's going to end up being 2i. So we can also solve using roots. If you only have a couple terms, keep that in mind. One of the big things that they try to get at you as you move forward is they try to make you think of things like this. Like they'll say you have x plus 5 squared plus, actually let's say minus 30. If we have something like this, one thing that a lot of people are going to do is they're going to try to double distribute here. So they're going to try to do x plus 5 times x plus 5, and then they're going to multiply it all out, set it equal to 0, factor, blah, blah, blah. Remember, roots exist. I can solve this as x plus 5 squared equals 30. I can then take the, oh, I shouldn't have done this. Let's change this to make it easier. So I can say x plus 5 minus 25 equals 0. So this will end up equaling 25. I take the square root of both sides, and I end up with x plus 5 equals plus or minus 5. And now my answer is just going to be x equals -5 plus or minus 5, which means my two answers are going to be -10 and 0. So that gives me both of the things that I'm dealing with here, and that's what roots are. Now that leads us right into the next example with completing the square. Completing the square is something that I know we talked about for sure, but it's something that was really tricky for a lot of people, so you just decided not to do it. If you're taking calculus, completing the square is absolutely 100% necessary. You can't get away from it. You have to do it because we deal with trig functions instead of dealing with just normal numbers, and if we do that, it's impossible to move on without using those, okay? So keep in mind, you have to use completing the square in calculus, period. The way that that works is, let's say that we have something that looks like this, where it's just a normal function, x squared plus bx plus c equals 0. In order to complete the square, you need to move the constant term to the other side. So you're left with x squared plus bx equals -c. Okay? And then what you're going to do is you are going to specifically complete the square. The way that you complete the square is you take b and you divide it by 2, and then you square it and add it to both sides. So this is going to end up being x squared plus bx plus b over 2 squared equals c plus, and I said add it to both sides, b over 2 squared. The beautiful thing about this is it will always factor into x plus that thing right there, or x plus b over 2 right there. Sorry, I circled the wrong one. So it's always going to factor into x plus or x minus, whatever b over 2 is, over 2 squared equals, and then this whole stuff on the other side. We'll go through an actual example with numbers in just a second, but that's what we have to do with completing the square, because now it's in the form, this whole thing on the right side is just a number. This thing right here, I can take the square root of, and when I take the square root of it, I can solve it like a normal problem. So let's look at completing the square. I want to find an example that's not necessarily in your book for the exercises. So let's look at completing the square. So we have an example that looks like this. So this is number 67. Let's do 68 in the book. So 68 is x squared plus 6x plus 2 equals 0. So now I'm going to move the constant to the other side. So I'm going to get x squared plus 6x equals negative 2. I'm going to take b over 2, so 6 over 2. And if it's negative, make sure you bring the negative with it. So b over 2 is 3. I'm going to square that, and I get 9. I'm going to add 9 to both sides. So I get x squared plus 6x plus 9 equals negative 2 plus 9. And then I'm going to get x squared plus, I'm going to factor the one side now. So I'm going to get x plus 3 squared equals 7. Square root. Now this is where the solving by roots comes in. And now it's going to be x plus 3 equals plus or minus the square root of 7. I can't do anything with this because it's not a nice square root, so I'm just going to leave it. So now it's going to be x equals negative 3 plus or minus the square root of 7, and I'm done. Okay? So again, leave it as square roots if you can, or I guess you have to leave it as square roots, so just make sure you leave it there. Okay? Solving by factoring, again, I'm not going to go through too much. The only thing that I think you guys might have questions on is the Brooklyn method, and remember that's just a times c. Again, I don't want to waste your time with reviewing and watching videos. So if you have questions on it, specifically ask me about them the next time you see me, but I don't want to just keep going over equations over and over and over and over and over again, because all of these examples in this book you actually know how to do. Okay? So the last thing I really want to talk about is completing the square when the coefficient is not equal to 1. So I don't want, when the coefficient is not equal to 1, we just have to kind of pay attention to that because it's a big deal. Okay, I'm not going to go through the entire example. I just want to talk you through it because it's the exact same as completing the square normally. So if we look at completing the coefficient or completing the square where the coefficient is not 1, so we have something like 3x squared minus 4x minus 5 equals 0. Leading coefficient right here is not 1. Since it's not 1, we are going to divide that whole thing by 3, the whole thing. So now it's gonna, the whole thing is, oops, that was a bad line. The whole thing is gonna get divided by 3, so it's gonna turn into x squared minus 4/3 x minus 5/3 equals 0. And then I'm gonna move this thing over to the other side. So now it's gonna be x squared minus 4/3 x equals 5/3. And now it's just in the same exact form, the numbers are just a little bit uglier. Keep in mind when you do b over 2, when you do this number b over 2, 4 over 3 divided by 2, this is the same thing as multiplying by 1/2, so 4/3 times 1/2, which will turn into 4/6, which will turn into 2/3. So b over 2 in this case will be 2/3. Okay? Now you would square that whole thing, and if you square that whole thing, you end up with 4 over 9. 4 over 9 is what you would add to both sides. You can see how this would be ugly and nasty because now we're dealing with a fraction instead of dealing with something else. Okay? But this whole thing, when we get done, would end up factoring into x, and this is a negative 4/3, which means that this would be a negative 4/3, which means this would be a negative and a negative. So this would factor into x minus 2/3 squared, and then all of this stuff on the other side. So I'll let you try to work through the rest of that example. Again, ask questions the next time you see me if you don't understand how to go through the next step. Okay, because all this is adding and combining fractions, which you know how to do. Okay, I know I said one last thing, but I want to just make sure that I talk about these. The quadratic formula, you need to know the quadratic formula. It's the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. I don't want to waste your time going through the quadratic formula and going through that kind of stuff because this video is already longer than I intended for it to be. But as you work your way through this, hopefully you can kind of understand what's going on with that. We've already gone through examples of grouping and making sure that we understand how grouping works in class together. We did our SAT review, so I want you to make sure that you understand that stuff. Just make sure that you understand all of the nuances with factoring and using radicals and everything like that. We will save equations involving radicals for next time when we're in person, because I'd like to talk about that more in person so that you can see the 3 specific cases. When we have equations with radicals on one or the other or both sides, I want to make sure that we actually can talk through that, because I'm not sure that's something we got to last year. So I want to make sure that we see that in person. Okay. So as we work through, make sure that you check on Google Classroom. We're kind of breaking this up into 2 days because it's a very long section. There's like 6 or 8 pages, 8 pages, I think, that have just example after example after example. Everything is something that you've seen in some capacity before, though. So you can do every single one of these, but I want to make sure that we talk about them before we move on and get too far in depth with everything, okay? Without keeping this video at 45 minutes or whatever it's turning into, okay? So please make sure that you ask questions. I'm going to put questions on Google Classroom, and it's just going to turn into a you practice them and you do over and over and over again what you can do and what you can't do. If you have questions, ask me, send me messages, whatever. Otherwise, save them for the next time that we come in person together, and I will have a homework quiz for you at the end of the hour, probably 2 or 3 questions where I just pick something random off of here and make sure that you can solve equations, okay? If you have questions, shoot them at me so that we can talk about them. Otherwise, I know that you guys can do this. I know that you're good at it already, so let's not make it more difficult than it needs to be, okay? So let me know if you have questions. Otherwise, good luck, and as always, have fun.